game changer. I'm a risk taker.
Hello, this is Team 𝗃𝗃𝗃𝗀𝗃 or Team ID SG7063. In this presentation, I'll be sharing with you about my code and my CoSpace journey. Team 𝗃𝗃𝗃𝗃𝗀𝗃 will be competing in CoSpace Rescue U19 as a solo team. My name is Matthew Tan and I am from Singapore. These are a few of my past competitions I have participated in. So, the preliminary challenge. In CoSpace Rescue, the mission is to rescue survivors in disaster zones and deliver them safely to designated safe zones. These are all simulated through various colored areas and objects. Some problems I found through the preliminary challenge is that since I have my code set up to tell my robot to search in certain areas of the map, eventually my robot will run out of resources in those areas. Hence, to solve this problem, I decided to double the number of areas that I get my robot to search in. So, instead of just searching in 3 areas, I now have it search in 6 areas. So, for the first half of the game, I tell my robot to search in the first 3 areas, and in the second half of the game, I get it to search in the other 3 areas, so that it will not run out of objects in those different areas. In conclusion, my robot was able to secure many sets of black, cyan, and red objects, which are also known as RGB sets, which, when deposited successfully, creates a superobject. These superobjects give many more points than normal objects, hence allowing me to achieve a high average score of 1700 per game. So, the main mission of CoSpace Rescue U19 is to gain as many points as possible through collecting and depositing objects, which can be done through various strategies. This mission can be broken down into 3 main groups of tasks. 1. Object deposition, 2. Object collection, and 3. Obstacle avoidance. By implementing different strategies to complete these tasks efficiently, the mission will be accomplished. These are a few of the AI algorithms I have implemented into my code to complete these 3 tasks efficiently. These are 2 tools I use frequently to help me when I do my competition. The first tool is the debug function. I use the debug function to find the current value of my variables. This helps me to find out what my robot is doing and why. This is especially helpful when debugging any bugs I have found with my program, as I am able to see what is going wrong and why. The second tool I use is Sticky Notes. I use Sticky Notes, which is an application on my computer, to note down any details on any problems I face. For example, if I am constantly running into traps, I can write that down and check the debug function to see if there's any details on it. If, for example, I have an algorithm that uses a certain variable to avoid traps, I can write down the value of it so that when I'm debugging later, I am able to check it and look at the algorithm to see which part of the sequence it's at and why it is not working. So, how do I implement new strategies? Well, after assigning the algorithms to the correct task group, I will be able to determine which part of the code it should go to. Once I have found that part, I will use the advanced actions and advanced conditions to add algorithms to further enhance my code. Most of these algorithms, if not all of them, require unique variables to work. So I create these variables using the variable creator function in the GUI. After implementing this algorithm, I will then run the code to find any bugs and issues with it. This is especially often with new algorithms that I've never implemented before. It is typical for them to have issues, as not everything works on the first try. So, using the 2 tools I mentioned earlier, I will note down any bugs I find and any problems with it, so that I'll be able to debug later. One example of an algorithm I implemented into my code is the superobject bank. It works by saving the coordinates of multiple superobjects at the same time, ensuring that my robot does not miss any superobjects generated while it is tracking a superobject. So, how did I come up with the idea? After practicing with my CCA mate, we discovered that our robots occasionally generated superobjects while already tracking one. hence replacing the coordinates of the first subobject and forgetting all about it. When we realized how many points we were losing due to this issue, we worked together to come up with a solution. We found that if we had an algorithm set up to save the coordinates of multiple subobjects, our robots would no longer have to replace the coordinates and hence be able to collect all generated subobjects efficiently. To further optimize this algorithm, I incorporated proximity prioritization to it, which is another algorithm I use. It allows the robot to track the closest subobject rather than tracking according to chronological order of when they are generated. I added this after noticing that even though my robot was right next to the second subobject, it only tracked the first object as I had not set it up yet. This is a simplified flowchart showing how the superobject bank is achieved. So, essentially, the superobject bank checks whether the superobject coordinates are updated and checks how many subobjects are already stored. So, if bank 1 is full, it will save the new superobject coordinates to the second bank, and henceforth. To ensure that this algorithm would work, we had to ensure that at all times the robot would be able to save new coordinates. Hence, whenever a superobject was picked up, we had to ensure that its respective coordinates were removed. And after its respective coordinates had been removed, we had to ensure that any bank information in the other banks were moved down. This created space for more information to be stored. So, on to debugging. Like I mentioned previously, after implementing an algorithm, especially a new one, it is typical for bugs to occur. So, using the tools from earlier, I will find these bugs by running the code and checking if there's any problems with the sequence. I will then use my sticky note to write it down and my debug function to find out when it occurs and what does it do. I then check what I suspect is the cause of the bug and attempt to fix it. I will then repeat this process and run it again and fix it again until it is completely fixed. And then I will proceed to do this for all my other algorithms to ensure that everything is working as intended. So, about my learning experience. My experience with CoSpaceRobot has taught me very much about coding and how robots function, as well as how to innovate. From this experience, I have also gained more confidence in innovating, as I find that the process of making a new algorithm reflects innovation, and it certainly worked well for me in this competition. The most important point that I wish to share with other CoSpace participants is to try new algorithms and strategies. You can do this in your own free time if you have access to CoSpace, as competition times are rather short, so making more complicated algorithms may be quite a struggle, as we do not have enough time to optimize fully. And that is the end of this presentation. Thank you all for your attention, and I wish all the finalists the best in their finals.